Hi, Algebra 1. Here we're going to be doing lessons 10 and 11 from Unit 1, the effect of extremes, meaning what happens to a data set and the statistics when you add an extreme value, like something really big or something really small. You'll see here that I have the dot plot with standard deviation Desmos graph open. You will be using that in lesson 10 here. And the first thing you're going to be doing in activity 10.2, we are going to skip 10.1. So 10.2, it says use the applet. Instead of using the applet, you're using your Desmos graph. So have that open and ready. And the first thing you're going to be doing is to create your dot plot with your data. The data you're going to be using is this data right there. So you're going to have to delete the data that's in your Desmos graph and put in that list of numbers. And then you're going to be going down and completing numbers 2 and 3. You are going to do all parts of 3, A, B, C, and D. And for each part, you're going to find the mean and the median. So for example, in A, after you add your two values that are greater than 14, you're going to find the mean and the median of your new data set. Now remember, the Desmos calculator will calculate those for you. Your job here is to start noticing what happens to my mean and my median as I change my data set. We are not going to do 4 and 5. So once you get to those, excuse me here, there we go. Once you get to those, we're not going to be doing those. So get going on those and start again when you're ready. Okay, I've added in the data that we provided up here. And as you can see, our data set does look pretty symmetric. Yeah, we don't have, maybe a dot right here that would make it perfectly symmetric, but overall it's pretty symmetric. We have our mean here and our median there. Part A asks you to add two values that are greater than 20, so I added, or greater than 14. So I added 16 and 20. You can see the dot for 16 on my graph, but 20 is now off the screen. As you know from Desmos, you can move that screen around. So now I can see 20, and I see my mean changed. My mean went up, it's now 10.7, but my median stayed the same. Now that's interesting. When we add bigger numbers, we would expect things to increase. The mean did, but the median is just that middle number. So adding in those larger numbers does not affect the median as much. Part B asks you to add two numbers that are less than 6, so I added 1 and 3. You can see in my list up there. And again, I'm going to scoot my dot plot over so I can see all of my points. My median again stayed the same, it's 10, but my mean this time did go down. Those lower numbers did bring the mean of the whole data set down, but the median, just being the middle number, still stayed the same. Part C asked you to add one value that's less than 6 and one value that's greater than 14. So I added 1 and 20, and I'm going to adjust my graph so you can see all of those. The mean this time, it did change, but it didn't change as much as when I was adding two large or two small numbers. So now it's 9.9, it was 9.7. And the median again stayed the same. Adding a number in the bottom and the top of my data set kept the middle number the same. Part D asked you to add the numbers 50 and 100 to my list, so you can see that I did. I am going to really change my graph so I can see those 2 points. There we go. And you'll see that the mean is now a lot bigger. The mean went from being about 9.7 to now it's 16.7. The median, however, still stayed the same. It's still 10. What we wanted you to see from this is that adding in extreme numbers will change the mean, but it might not necessarily change the median. The middle number is not as affected by those extreme values as the mean is. Going on to activity 10.3, you're going to create a possible dot plot with at least 10 values, so 10 data points for each of the conditions listed. Instead of doing each, I want you to choose one. And I want you to do a really good job with that one. So choose one of these and create a dot plot with at least 10 data points. At least 3 of the values have to be different. That means you can't use the same number for every data point. And when you're done, I want you to sketch what that ends up looking like in your workbook. So use your Desmos calculator to play around, create that dot plot, and when you're done, sketch it in your workbook and get it stamped. If you'd like some extra stamps, do more than one. I'm now looking at the lesson summary for lesson 10. There are some really good things in here that you need to make note of, so be there right now. So we're looking at the mean and median. Which one should we use to describe the center of a data set? And the answer is that it depends. The mean gives equal importance to each value when finding the center, which means that each data point plays a role in finding the mean. The mean usually represents the values well when the data has a symmetric distribution, and that's going to be important. So if the data is symmetric, the mean is a good value to use. The median will tell you the middle value, and so it's not going to be as affected by those extreme values, which means that the median is more important or more appropriate for data that is not symmetric. Okay, so those are two things that you're going to want to pay attention to in your summary. Here's some examples from your lesson summary. Here we have some data that is symmetric. And so when it's symmetric, again, we want to use the mean to describe the center of the data. Down here, we have some data that's skewed, which means it's not symmetric. And if it's not symmetric, the median is a better description of the center of the data because it's not going to be affected by these extreme values out here. When we get into lesson 11 here, we're actually going to skip 11.1. 11.2 and 11.3 is going to be done using a Desmos activity. That link is on Canvas. And then when you're done with that, I want you to come back because there are some important things in the summary that we need to talk about. Okay, in your lesson summary, it's really talking about when do you use the mean or the median and when do you use the MAD or the IQR when describing your data. Essentially, guys, if it's symmetric, if your data is symmetric like you have here, you'll use the mean to describe the center, okay? And you'll use the MAD or the mean absolute deviation to describe the variability. And that works because the MAD, if you remember, you found the mean when you were calculating that, and so it depends on the mean, and so they go together. If your data is non-symmetric, like you can see in these box plots here, the different quartiles or the different sections of the box plot are all very different sizes. So it's non-symmetric. Then you would use the median to describe the center because it's not going to be as affected by large or small values or extremes. And then you're going to use the IQR or the interquartile range to describe the variability. And that's because the interquartile range, which is essentially the distance from here to here, is not going to be affected by those maximum or minimum values. And so if it's non-symmetric, use the median to describe the center and the IQR to describe variability.